Hello, stats students. Sorry I can't be there today. I know that you're going to be on your best behavior for the sub. So we're going to jump back into our Chapter 8 notes. I want to remind you of the fact that this is on the second page. Okay, I want you to try to take a second and read the scenario. So it's the same scenario we had with central pressure and max wind speed, but they give you an equation for the actual relationship between the two things. I want you to try this without my help first, and then I'll kind of explain over what it should mean. But take a second and see if you can figure out what the slope means in context, and if the y-intercept has a meaningful interpretation. So just take a minute and do that, and then pause the video. When you come back, I'll explain. Okay, so in this case, our y-intercept is 955, so it should be, it should make sense most of the time. In this case, it's like really high up, so the y-intercept is always where your x value is 0, but your y value is whatever that number is. So in this case, it would be 955 knots for a speed of wind, which is crazy. So it doesn't really make sense in this scenario. Normally it would. The slope will actually make sense because if you think about that as a number, negative 0.897, that is 897 1,000ths. Okay? What that means is for every 800, so for every, if you think about it as like rise over run, for every 897 knots, you are, that's how much you're rising. So for every 897 knots that you're increasing, you're decreasing, if you think about it, this is really a negative problem. You're decreasing, this is your run, so rise over run, by 1,000 in central pressure. So again, that's for every 897 that you increase in knots for wind speed, you're decreasing your central pressure by 1,000. Okay? I want you to do the same thing with the second question below this. Try to create a linear relationship that shows the scenario. You're writing an equation. I actually don't care if you write it as y hat equals and then use your variables that way. Your textbook likes to do a lot of where you actually use the variable in the y equals instead of y hat. So if you do that, I'll show you both ways, but I want you to try it out first. Okay, so you should either have y hat equals 19.99 plus 0.25x, or you can do it in terms of your variable. So your explanatory variable is your miles that you drive. So that's why it's in for your x value. And then your response variable, or your y value, is your rental cost. Okay, so it's the same thing. I don't really mind if you do either equation. All right, I would like for you to try this one out for me. So we're talking about a scatter plot of house prices in thousands of dollars versus house in thousands of dollars in feet in Saratoga, New York, very close to where I'm going to be this weekend. It shows a relationship that is straight with only moderate scatter and no outliers, so we can move forward with our regression. The correlation between house price and house size is 0.77, so it's pretty strong. And the equation of the linear model is price equals all that. What does the slope of 94.45 mean? I want you to try each of these, especially number 5. I think you guys can interpret on your own, but again, I'll have the answers up in a second. All right, guys, so number 4, what does the slope of the 94.45 mean? So remember, it's like 94.45 over 1, if you think about it that way. If it helps, draw a picture of what the scenario is, that might help you interpret. But remember, it's rise over run, so price over size. If you were to do it in 1,000 square feet, it might make a little bit more sense because of the price of houses is not $94.45. But the easiest way to interpret it is to say an increase in home size of 1,000 square feet is associated with an increase in price of about $94,450 on average. So I just put it over 1,000 instead, so it makes a little bit more sense. Number 5, units are thousands of dollars per thousand of square feet. Number 6, you have to plug in the 2,000 square feet to size, and that's about $188,900 on average. So folks, just be careful when you plug in that 2,000 square feet. This model is in thousands, so you want to change that to 2 when you plug it in. Number 7, it's a no, because in our case, our y-intercept would mean that if you got a I'm sorry, I'm like choking. If you got a house, that would be like a negative price almost. But if you think about it, your y value would be 0. So it'd be like a price of 0 with a square footage that's negative, which doesn't make sense. So again, think about if you were to graph it, your y-intercept would be that negative 3.17. So it'd be a price of a price of negative 3.117 and 0 for your size. So it'd be 0 square footage, which would not be a house. That would be a box. Not even a box. All right. The line of best fit is the line for which the sum of the squared residuals is smallest of all. We can call it the least squares line. We already talked about that in our reading guide. So move on to the next question. All right. So what I want to point out to you is that your slope, which they call B in these problems, is your correlation times the standard deviation of both of those values. I showed you that before. I'm not going to make you calculate that, but you should be able to interpret it later. The big thing to notice is if we standardize everything, meaning we change our mean to 0 and our standard deviation to 1, what would happen to this? So if your standard deviation is 1, your slope ends up being the same thing as your correlation coefficient. Okay? The next 2 examples are not anything to do with that, but it says we can create models for our scatter plot. You can use one of 2 things. So if you've never seen this formula, don't worry about it, but y minus y1 equals m times x minus x1 is something called point slope form. It's a lot easier to navigate, and if you take calculus, you might be using it. Or you can use y equals mx plus b. I'm going to do the first one with you, and then I want you to try the next one without my help, and I'll give you the answer after. In fact, I'll have you check your answer with the ed puzzle question that I'm going to pause it at. Okay, so you can use either formula. I'm going to use the one that you guys are used to. So if this is my point, 320, and my slope is 4, I would plug those numbers in for x and y, and the slope is 4, right? So our y value would be 20, our slope is 4, our x value is 3, and I can solve for b. Okay, so again, your textbook uses b as slope, so don't get confused. This is our standard form. So 20 equals 12 plus b. Subtract the 12, and you would get b equals 8. So your equation would look like y equals 8 plus 4x. Okay, and if they are using data points, then it would be y hat equals 8 plus 4x. All right. For number 12, I want you to try it, and then I will show the answer in a minute. All right, so number 12, you should have had y equals 17 minus 2.5x. Okay, and you don't necessarily need the hat because we don't know that this is raw data, so that would work. Alrighty. Same thing, I want you to try this out. Use the fact that now we're using, it's a slightly different formula because they're now giving us the mean and standard deviation. Okay, so we're going to use y bar equals a plus b x bar. So notice that you can literally plug in the x bar and the y bar. And the fact that our b value comes from your r and standard deviation, you want to look at the previous page if you forget what the formula looks like. But you guys should be good to answer these questions. If you have trouble on E and F, I'll explain those afterwards, but just try A through D. I'll pop up answers, and then I'll explain E and F. All right, so A is yes, because these are both quantitative variables, the data looks straight enough, and there's no outliers. Okay, so part B, you had to use the formula from the previous page. So it's literally your correlation coefficient times the standard deviation of y over standard deviation of x. So that's what it is. So your slope comes out to 4.4. Letter C, maybe you didn't recognize immediately, but they gave you the mean of height and weight, which means they have to be a coordinate. And then you can use those 2 points to find the y-intercept. So remember, you can just plug the 68 in for x, 150 would be y. You already found your slope was 4.4, so then you could solve for b, okay? Really a, sorry. Your a value would end up being negative 149. So if you write the equation, again, they want you to use meaningful variables, so you'd really say like weight hat equals negative 149 plus 4.4 height. But you could also just use y bar in this case, because they're using the mean, equals negative 149 plus 4.4, and then x bar. Okay, the reason they use the means for these is usually they don't even give them to you. This is kind of a rare case, but if they give you the means, then use them. The mean is literally like you're averaging all the points together. So if you think about it, it's almost like we're looking at the residuals. Alrighty. I just thought this was kind of a fun fact that Sir Francis Galton related the heights of sons to the heights of their fathers with a regression, and the slope of his line was less than 1. That means that sons of tall fathers were tall, but not as much above average height as their fathers had been. So sons of short fathers were short, but generally not as far from the mean as their fathers. So he called it the index of correlation, but we call it the correlation coefficient. Alrighty. So folks, these two, the one 9 through 12 can be a little bit tricky. So I'll have you try the next one without my help, but we're going to do the first one together. It can just be like a little tricky to get through, especially because your correlation coefficient is 0.77. Remember, if you standardize your scores, then your correlation coefficient matches your standard deviation. In this case, use that to help you answer the following questions. So it says you go to an open house and find that the home is 1 standard deviation above the mean in size. What would you guess about all of its prices? So that literally just means that the price has to be 0.77 standard deviations above the mean, because your correlation coefficient will match your standard deviation in that case, and it's your slope as well. So for number 10, it says you read an ad for a house that's priced 2 standard deviations above the mean. What would that mean about the size? It would be 2 times that 0.77, so it'd be 1.54 standard deviations above the mean. So you're matching your correlation coefficient and your standard deviation. Friend tells you that your size is in square meters, is 1.5 standard deviations of the mean. What would you guess about the size in square feet? And the nice thing is, because you standardized, it's the same. It's still 1.5. Remember, your units, that's why we standardized, to make the units the same. And then number 12, I think you could probably figure out, but I'll give you the answers and just pause it to figure out if you understand where it's coming from. But for A, now they give you your mean and standard deviation for each of those scenarios, but how many standard deviations below the mean is this student's height of 60 inches? It ends up being 2. And the reason is because if you look at the standard deviation, and that's your height, 2 standard deviations would be 8 units. 60 is 8 units away from 68, which is the average. So hopefully that makes sense. If you have any questions about this too, I can always answer them on Tuesday. But using the regression factor R, how many standard deviations below the mean weight should we expect the student's weight to be? So B, if it's 2 standard deviations, it's 2 times that standard deviation, so it's 1.4. How many pounds is that? So you have to do 1.4 times 25, because that's your Y value, your Y standard deviation. And that comes out to be 35. And then what's the predicted weight? So you want to do your actual minus 35, which is going to give you the 115 pounds. All right. Take a second and again try 13 through 17. I'm going to have you pause the video and then I will have answers up. All right, so number 13 should have been negative. It indicates that the price is lower than the typical home size. Okay. So because you want to get a better deal, it should be negative because, again, you want to pay less, right? 14 was 280,233. Because you're just plugging that into the equation, right? So very similar to one we already did. Number 15 is 19,767. Again, you should be able to calculate that. 16A, if you estimate her weight, it's 159 pounds. B was negative 15. Okay, it should be a negative number. And then 17, excuse me. The 65-inch tall person was 137 pounds. So it was 18 pounds heavier would be 155. Okay. All right, and the last few things, folks, is you can use the same regression line and switch your variables, but you have to recalculate. So you're welcome to switch the variables, but then you actually have to recalculate your best fit line. I've already talked about extrapolation a few times, so I'm not going to explain it further, but predictions are extrapolation. Okay, you don't really want to do that very often. And then the last problem, you guys already know how to enter in your data into the calculator, but you have to use number 8 to make it match what we've done. I want you to try 18 through 20 as well, but just pause the video and then I'll give you answers again. All right, so number 18, oh, and there's the bell. Weight is explanatory, height is response. Your equation should have been y equals 51.2 plus 0.112x. And then for number 20, you have to plug in the 200, and it was 73.6 inches tall. So if you have any questions, I'll be back on Tuesday, and I'll see you then.